What we're going to talk about today are graphing lines using points and slope. Let's look at a special case of the point-slope form. And in this example, we're going to substitute x1 equals 0, which is basically gives us a y1 of b, which is the y-intercept. So let's look at this relationship once again, which is the point-intercept form. Substituting x1 for 0, we have y1 equal b by definition, where y1b is the y-intercept since x is equal to 0. Now in this relationship right here, we can solve for y by adding b on both sides of this equation. We see the b's cancel out on the left side, and that gives us y equal mx plus b. Pass through the point here of 5, because that was what we calculated last time. So let's look at another example of the slope-intercept form. We'll find an equation having a slope m and a y-intercept of -4. In other words, we have this relationship. Substituting m for 5 and b for -4, we have this equation of y equal 5x minus 4. So when we substitute x equals 0, we have y equals to -4. So x equals 0 and y equals -4. So that's one point here, and it intercepts that axis at -4, or the y-axis at -4. Now let's look at the point 1, 1. Okay, so when we substitute 1 in here, we have 5 minus 4 is equal to 1. So that's a point. Then we can draw a line between these 2 points as shown. Another example. Find equation having points -2 and 3 and 1 and -2. So we have a line that passes through these 2 points, and this is the 2-point form of a line. Again, here we use the definition of a slope. So here in this case we have y2 is equal to 3 and y1 equal to -3. So 3 minus -3 is plus 6, and -2 for x2 and 1 for x1. So this yields 6 over -3, which yields a slope of -2. So we have a slope of -2. At this point, we're going to look at -2 and 3 and do a slope of -2, which is the same thing as going 2 steps to the left and 1 step upward. Alright? But we can use this relationship of 1 and -3 here, because that's the other point that we have. Okay? So here we have y minus y1 equals m times x minus x1. So this is the point slope form. And we can substitute as a check where x is -2 in here, x1, and y1 equal 3, shown here. Solving, we get y minus 3 using the distributive property here. We got -2x, and then -2 minus -2 yields a -4, and then adding 3 on both sides of this equation, where the 3's cancel out on the left side, yields -2x minus 1, since -4 plus 3 here is -1, and here we just drop down to -2. So here again we have a slope of -2 and a y-intercept of -1. So when x is equal to 0, it intersects this y-axis at -1, as shown here. So this is known as the slope-intercept form right here, since we're given the slope and we're given the intercept. Whereas in this case we're given the point and the slope. This is known as the standard form, where we have all the variables on one side, and this is all by definition. So let's summarize in finding the equation of a line. So here I have what's given, and here's what we use. So if we're given a point x1 and y1 and a slope m, you use the point slope form. This is given as follows. Here we're given the point and we're given the slope. Therefore, we use this to find the equation of the line. Since this is the slope and our coordinates for x1 and y1 are shown here. If we're given the slope and the y-intercept b, we use the slope-intercept form, given by as follows. So here's the y-intercept b and the slope m. And if we're given 2 points, x1, y1, x2, and y2, then we use the 2-point form shown here, which is more general than the one we have here at the point slope form. Okay, so once you find this point, you can calculate m. And then from there, you got the slope as y2 over y1, x2 over y1. And then all these equations can be written in terms of the standard form ax plus by equals c. Now you note here, once we find the slope of this point, of these 2 points associated with it, then we can use the slope-intercept form or the point slope form to find the equation of the line. Since we already have the slope, we can use one of the ordered pairs x1 and y1 or x2 and y2 to find the equation of the line.